We can start. Guys, sorry for the delay. There was some technical issues, and therefore we have shared the new link to all of you, and you can please consider sharing it with the list whom with you have shared the list. So here we have our own alumni from 2K6 batch, Dr. Sohini Roy Chaudhary, and it has always been my pleasure when I introduce my own student. And to be very honest, she was the one of those students when I joined BIT Mesra. She was in her final year, so I know her personally during those days, and nice to be connected through her on LinkedIn. And she was kind enough to accept the invitation to address you all. So without making much delay in the process, let me introduce her current profile. She is the co-founder and curriculum director at an edtech startup called FourthBrain.ai. The company provides specialized hands-on courses in the field of machine learning and artificial intelligence, the buzzword for today's. Dr. Roy Chaudhary comes from both the academic and industry worlds of applied machine learning and artificial intelligence. Prior to her entrepreneurial venture, she was the senior manager of autonomous drive and head of university relations at Volvo Cars USA. And prior to that, a tenure track assistant professor in electrical and computer engineering at a University of Washington campus. She has applied machine learning and artificial intelligence models on problems ranging from epidemiology, diagnosis medicine, supply chain management, computer vision detection modules, and e-commerce streamlining. Till date, she has over 50 academic research papers and 19 patents to her credit. And she continues to create educational contents through blogs in Towards Data Science and her YouTube channel, AI with Sohini. So I'm sure that after her session, you will be inclined to go to her channel and see what she's doing. Over to you, Sohini.
Thank you so much, Vishal, for the kind words, and it's actually great to be here. Somehow, I always had, so I've given talks at IIT Delhi. I've given talks at different IITs and NITs. Somehow, coming back to BIT is very special. So thanks, for having me. I'll get straight to the talk, and I highly appreciate questions, and we can wait for them till the end, or you can actually post them in the chat if that works better. Vishal, can you let me know if the screen is visible or not?
Then yes, the screen is visible, Sohini. It's perfectly fine.
Okay. So welcome to the talk today. It's called Machine Learning Engineering Solutions for End-to-End Product Creation. So I've tried to put in all my knowledge as an educator, as an industry professional, and trying to see what are the gaps right now, which is stopping machine learning solutions to actually see the light of day, to come out into production, to come out in the market. So this would be a talk about how that gap can be bridged and what are the different roles, what are the different trainings that need to happen so that we see more machine learning or more AI actually becoming products as such. So the key question we should start with is, why are machine learning solutions important? We talk about machine learning everywhere. Is it really relevant? I mean, why do you really need it? So let's look at a specific use case, which is computer vision use case in this case. So this is a slide that I use a lot just to get some response from the room. I know today we are not going to get response from the room, but let's see if we can all do this individually on our own. This is called the Imagenet challenge. So back in 2007, there was this huge data set. It was over 1 million images that was released, and the goal was to enable object detection using deep learning. So if you look at this, IVLC challenge, it came out in different versions after that. There was a 2012 version after that as well. So the question here is, find the cat. How long does it take for your eyes to settle on the cat? The answer is, well, it's pretty simple. If for everything else, it's a no. Just for the cat, it's yes. So if we just have to find the cat in this image, it's pretty fast. But now let's try a harder problem. These are retinal images. So these are actually images of the back of the eye where the information actually goes back to the brain. So now in such a case, if your problem becomes find pathology, how long would it take you to do that? You see, find a cat, instant your eye went there. But now take a minute, look into the images, that there's some things which look a little off here as well. There are some things that look a little weird here. There's some things that are weird here, and then there's a huge thing which is weird here. Ideally, if you had to play safe, you say all of these have pathology, right? But that's not the case. The truth is the top right and the bottom left, these are the two which actually have, so peripapillary atrophy and neovascularization, these are both correlated to pathology. However, this cloud-like structure, it's just myelination, and it's not a pathology at all. And the same way, this dark spot here, this is just an eye freckle, so it's called a nevus, and again, it's in no way it's pathological. So ideally, what we are trying to say is to train the human brain to find objects, it's relatively easy. But then if you're trying to train the human brain to again find pathology or to do harder tasks, there's a huge amount of training that has to happen. However, machine learning can highly automate this process. So machine learning enables automated decision making and predictions based on previously learned patterns. So in the problem that I showed you for medical image detection, where is the pathology? What we were able to do is take a standard model which was trained on normal objects and then fine tune that for medical images. So the number of medical images required to train a system was significantly low in that case. So that was an example of transfer learning, and machine learning enables that. Now let's look at an e-commerce use case. With the lockdowns and everything that has happened for over the past year and a half, we are all very comfortable now doing online shopping. Everybody does that. But now think about it. This is actually coming from a very recent paper. It is, and the archive link is in down below. It's called OPAM, so online purchasing, online purchasing behavior analysis using machine learning. And so you can even search it up if you want. But what we do there is, let's see that we are all sitting at home and we are purchasing things online. Based off of our purchasing behavior, the timestamp behavior is becoming a part of a CSV file, or it's becoming a table. And then if the same person is returning to the site multiple times, then these can actually be conglomerated together to now create a user journey. So if you have been shopping on Amazon, if you've been shopping on Target, on Walmart, as many number of times you go sign up, they are actually creating one huge file table corresponding to how many times you have actually visited the site. And now the primary contributions you can do is based off, if you log back in again, now it is possible to classify, are you going to purchase or not? And also there is a possibility of categorizing. Are you an impulsive buyer? Are you a new buyer? Are you a returning buyer? So there is, the step one would be classification. Step two would be clustering. And also we are now able to do a user behavior analysis. Is how hard is this person going to be to convert him from being a new user to a returning user, or how difficult is it going to be, or can you just show a coupon to this user and this user is going to make the purchase today or not? So now we are literally able to see these different clustering behaviors and also figure out how difficult or how spread apart they are, so that you understand how difficult it is to convert them from one user category to the other. So by this use case, we learn that machine learning enables categorization and purchasing patterns, which further aids personalization. So think about if you go to Amazon and it finds very relevant products for you. That's the very relevant ones that are actually suggested to you. So that's personalization to a huge amount. And also, if this automated inventory thing works perfectly, you will always find the products that are there for you, because the system will automatically gauge that if this user is online, he probably needs this product. Right? So if this automatic pattern recognition works, then it can highly help personalization and making all of our lives easier, right? For the vendors as well as for the buyers. Now we understand, okay, there's a certain amount of automation that is required that machine learning is capable of providing to us. Now let's look at some of the challenges faced by the ML products. Now let's say that if the same e-commerce example that I just told you, let's say you work for a company or you've come up with a great startup, and what you've done is you've taken a store A. So let's say that this is Target, right? And you've taken, Target is your vendor of client of choice. They come and give you information about the buying patterns online. And you use this data in order to train an ML model. Great. And so now you see everybody is getting what they want for Target, because they have a certain streamlined application format. They have a way in which queues are formed. So as soon as you take the data from Target, you are able to provide customers with all of the products from Target very easily. But now let's say you sign up Walmart, right? The same thing. It's again another store. It has very similar products. However, the way in which the customers wait for products, or the way in which their lines are formed, for checkout, might be very different. So now, if you, let's say, you don't train on Walmart, but you just use the data and you pass it to the same machine learning model, now you're saying that you're getting a gobbledygook. So you're not able to predict, what are the products people need. You're not able to predict, and so you're overstocking. And for some products, you end up understocking. So your customers are not happy anymore. So what happened? What was the problem here? You have a very well-trained ML model. You just changed the store and things are not working anymore. Why did this happen? Well, the questions that you need to be thinking about in order to have a good deployment in this case is, how do you detect if the test data at production time is not giving appropriate results? Or how do you monitor an ML model and identify there is a clear need of retraining? So ideally, in this case, what you should have done is taken some data from Walmart and retrained on it. So, before serving it up to the customers of Walmart. But why? How would you even figure out if there is a need to it? That's what is called ML monitoring. Now, ML monitoring, again, you will hear these two words a lot, and that's called data drift versus concept drift. So the first concept, the data drift, it means there is change in the underlying data distribution. Like I said, as soon as you moved from Target to Walmart, the way in which the queues were formed, it was the time to service, it was the time to stock objects, or to create the inventory list, that might be completely different. So if you had actually gone back and looked at these queue times, you would have seen that the underlying data distribution is completely different. And that should have given you a cue that, well, I think I need to retrain it on Walmart. Just serving up the model is not going to help. And the other facet is concept drift. So machine learning models, if you keep them in the field for a long time without retraining them, they can actually go stale. And you might wonder, go stale, but that's actually, that can happen. Or what can happen is that the correlation between input to the output can heavily change. And this change can happen due to a multiple number of reasons. It could be the compression factor. It could be just the way in which the data is getting logged. It could be just the platform. Everything might be different, because of which the input to output correlations may shift. And these are factors that you really need to monitor so that you figure out that now is the time to actually retrain. I actually have a few videos on my channel about ML monitoring. So do check them out if you want to know some of the softwares and systems required to do that. Now let's get into production. So let's say that now you understand machine learning is important. Now you understand what are the parameters that need to be monitored. Now you need to understand how to productionalize it, right? How to generate a product out of it. So the key terms that have to be kept in mind here is called the CICD pipeline. The CI stands for continuous integration and CD stands for continuous deployment. So a CI/CD pipeline, if you want to take the textbook definition for it, it automates your software. And what the pipeline does, it builds new code, it runs new continuous integrations, and it deploys a new version of the application. So think about it. Let's say that you graduate, you work in a large company. Your team does not just comprise of you. There are multiple people who are working in the same team. All of them are committing to a code, right? So typically it's a Git repository where everybody is committing code. And after a certain amount of time, you say, okay, now the code is ready. Now we need to deploy it. So there are a certain number of steps that have to be taken from the time people all committed the code to the time that you can actually deploy it as a product. Now let's look at those steps individually. So let's say you have a source code, again, you're all team committed towards. Then the first step is you need to generate a run. And ideally in these cases, these are called the Docker runs. Docker is another word for containerizing or orchestration. Whenever you want to really see something in the field, you don't really let go of Python files or IPython notebooks. You are supposed to create snapshots or containerized images of your algorithms. And that is what we are trying to do in this case by doing the Docker run. So then we do builds. This is called a cloud build. What a cloud build does is it generates containerized images using all of the raw materials you have already, uncovered. So let's say there is a IPython notebook, then you have, data, right? So it's the data is existing in some of the bit buckets in your cloud. What this cloud build will do, it will generate a build, or it will generate this dockerized container or this image that will then be taken to production. The next step, of course, is to test and monitor. Now, after you've generated your build, you have to ensure that you connect your container to some sort of logging platform. Because I just told you, right, there is data drift, there is concept drift. How do you ensure that for live data streams, you are taking care of all of these metrics and you're monitoring them? So there has to be some amount of unit testing, as well as there is some amount of logging that has to happen. So there is this testing, logging, monitoring that has to happen. And finally, what you do is you just make it available to all customers, which is, that means you're deploying it at scale, and then you just monitor its progress, right? So ideally, in this case, Kubernetes orchestration can help it a huge way. And I'll be frank here is, people generally who know a lot of machine learning, they don't know a lot of Kubernetes. And the people know a lot of Kubernetes, they generally don't know a lot of machine learning. And that is the gap that the industry is actually facing. Because if you don't know the entire system, if you don't know the entire pipeline, you will be lacking in the way in which you think about scalability. And so there will be some bottlenecks or some impediments when you face as soon as you're trying to scale something up over a demo. Like, think about your final project, right? You can go and demo a short version, but as soon as you have to serve from 2 clients, if you go to 200 clients to 2000 clients, that's where you have to start thinking about scale. And if the scale was something you had thought about when you were designing your product, then life would have been so much easier, and then you would have no downtime and all of your customers would be happy. So that is the key that Kubernetes orchestration allows, so that now you can scale up and extend your pipelines with much more ease than before. So now let's look at some of the key factors that I talked about. And I know I glanced through them, so I just wanted to discuss them in a little more detail. So first question, what is Kubernetes and how can it possibly help? Now, I'll give you an example of Kubernetes versus Docker. As I mentioned before, Docker is just making a snapshot or a containerized version of the Python notebooks of all of the algorithms and definitions and the functions, along with the data to put together in a container, right? So that's just Dockerization. And Kubernetes is just the orchestration. So if you have multiple containers, how do you make sure which one works and in a seamless way? So let me show you 2 use cases, and then you'll be able to figure out why the need for Kubernetes or Docker, right? So there was this case of Bose products. Everybody should be well aware of Bose products, right? The sound systems. And there was a huge demand for the growing number of products that Bose was handling. They were just creating a huge variety in products. And it was becoming very hard to maintain or to create balance between what are the different products that are coming up, and to ensure inventory and making sure that they have an idea of how people are purchasing all of this. So scaling across different products became a problem. So you see, the key issue here was they had a lot of products to begin with. Now, Kubernetes was scaled as an Internet of Things. PaaS here means platform as a service. So Kubernetes became the solution on AWS. It became the platform as a service, which was then able to unify all of this and all of the scaling across the different products. And the result, what the industry saw, was the platform now enables over 30,000 non-production deployments across dozens of microservices per year. And in 2018, there were about 1250 plus production deployments that were done. So you see, because of Kubernetes orchestration, Bose was easily able to span out and then now see that there are so many other products which can be controlled in a centralized sort of a way. Now let's see Docker. When can Docker be useful? PayPal, everybody knows PayPal, right? So we all use it a lot, especially after, closure. So PayPal processes over 200 plus transactions per second. That's a huge number of transactions that's going on. The key issue that was happening with PayPal was deployment on different architectures resulted in maintenance and deployment challenges. So think about an app that is getting launched maybe in India, then another one that is getting launched in Europe, another one that is getting launched in Australia. And everything is at every single point of time, they might have a different operating system. They might have a different basic packages, and it was very hard to control how these different applications were running and servicing because they were just getting spawned across very different kind of virtual machines. So Docker resulted in a unified delivery because now you have a snapshot, you have a containerized format where you will always have the same version of Python, you will have the same version of NumPy, you will have the same version of all of the libraries put together, and you don't really have to go through these versioning errors. So Docker resulted in a unified delivery and a centralized container management system, because of which PayPal migrated to 700 plus applications to Docker with over 200,000 plus containers. And they're running it very effectively. So think about it. You need Docker when you have a very small snapshot in time. But if you have an application that has to go from one step to the next step to the next step to the next step, then that is your Kubernetes orchestration. So let's look at what I just said in a figurative fashion. So let's say that you have an app that starts somewhere. Like I said, let's say that this starts in India. And then I have another app, the same version of the app. Let's say now I start that in US. And then there is another one that starts in Europe. For each and every one of these applications, there's always going to be a DNS. So you need to say, you need to be able to map that with a certain URL, correct? And that URL needs to be mapped to an IP address. Now, Kubernetes, what it allows you to do, it does super fast naming convention so that all the containers can now find each other. So if one container goes down or if one node is off, you can automatically orchestrate the same container to come out on some other virtual machine. So that's what Kubernetes makes our life super easy. You don't even need to think which machine at all. You do not need to remember port names. Kubernetes does this all by itself. So let's take an example. You are working on a company or with a complete product team, and they are all committing towards code, like I mentioned. So this is the Git code, right? So you put it into a GitLab. And from the Git, then you create a build, right? So you're in the Docker run and you're creating the build process. Once you have built all of this, now consider all of the configuration files, the source files, the libraries, all of them need to be now packaged into your Docker container. Once you have that, then you do a construct. So now you're preparing for your CD. So up until the Docker process, this is your CI. So you've done your continuous integration, but now you're trying to do continuous deployment. So in order to do continuous deployment, then there are these other Helm packages that can help you construct or create the continuous deployment piece. And finally, you get into a load balancer. So the load balancer, what you may think that, okay, it's balancing the load across the different nodes. There is some amount of balancing that is happening, but here the load balancer is just ensuring that the deployment is coming out as a URL. So it's just exposing your deployment as an HTTPS. So now you can actually view whatever you created as a URL address. So ideally, a Kubernetes architecture would look something like this. So there is a master node, which is orchestrating all of the different functions. And then there are a lot of worker nodes. And ideally, you can, whenever you spawn up a cluster, you can literally mention how many worker nodes you want. And this would be based off of the scale that you're anticipating. So let's say that, again, you were in that e-commerce shopping app, and you have two clients right now, and you think that 3 nodes is enough to serve them all. However, now if you are going to, from Target to Walmart to, a few more, so 20 customers, you have to increase the quota and you have to increase the number of worker nodes so that you are now able to service them all with minimum downtime, right? So then that is the constant orchestration between the master node and the worker nodes. And also then there is this image registry. So this image registry, this is actually the Dockerized images that I was talking about. So let's say there is a Docker container corresponding to just loading the data. There could be a Docker container corresponding to just pre-processing the data. There could be a Docker container corresponding to then, the model predict, and then there is one corresponding to actually showing everything. So the final Flask or the front end. So then these could be the different Docker files or different Docker images that are already on your server that have been pushed to the server to make sure all of the application looks seamless to the customer. So the customer, it's just going to be, okay, one button click, next button click, next button click, but every single page, you can actually close it up using these Docker containers. Now, one of the key facets that, and I'll show you an example in a bit, but one of the key facets of what, this is called a concept actually for Kubernetes, is the concept of rolling update. Now, even in machine learning, like I mentioned, so, if you just keep a machine learning model for a long time, it will go stale. That means the, correlations will drift. So what do you do in that case? So let's say, again, you have a service, and in this case, you have, again, your e-commerce app, and you have, it's running in 3 different nodes. It can be 3 different nodes in US, 3 different nodes in India, whatever. And now you have an updated version. So it was not serving well to a certain number of population. So now let's say you have a version 2. So what's going to happen is a pod or a container corresponding to this version 2 is automatically going to get spawned into this node 3. And then the service will switch to this new version 2, and it will stop service to V1, and then V1 will disappear. Same thing will happen to node 2. And then it will start service, it will stop service to V1, and it will disappear. What this process is also known as is the Canary Build, C-A-N-A-R-Y, Canary Build. What the Canary Build does is every time a new version comes in, at this point, what's happening is the user data is being used by V2 as well as by V1. So V2 is just sneaking up on you, and it's seeing if the data is now giving you the right results or not. And if the answer is yes, then the service switches to V2 and it stops service to V1, and then V1 is completely taken away. And by now you see that a rolling update has been done. So it's not all of a sudden, one night, all of the applications shut down and the next day it starts running again. That's the reason why we call it a rolling update. And that's the reason Canary Build is the best one, which is supported by Kubernetes orchestration, so that the customers do not see any downtime. And in their mind, the model just got better. But they should not face at any point of time that the server is down or things like that, right? Now, this is actually an example of the Kubernetes orchestration that I wanted to share with you. So this was, again, this is a computer vision backend. So think about that you are working for this company, and your client has suggested, I want an image tagging system. So what kind of, that's the kind of, package that they want. So your company is providing them with this URL or this service. You see, this is a URL. What this does is, as soon as you upload an image, it will tell you what are the contents of that image. Is this an outdoor image? Is this a face image? Is this an indoor image? Is this a medical image? What is it? So it's supposed to automatically tag images, right? So in this case, let's say the first thing that you did, you just picked a ResNet 50 model and then you deployed it. So now let's test it. If I take a very easy image such as this and I say upload and analyze, you see the tags are coming as seashore. It's very confident that seashore, it's 77%. Sandbar, well, there's some amount of sand, but there is no wreckage. But then the probability of that is pretty low as well. So in this case, you're saying that it's doing pretty well. Now let's take another image, which is going to be a medical image in this case. So it's never seen a medical image before. And now I just say, hit upload and analyze. And as soon as this happens, now you see the results are all off. It says it's a jack-o'-lantern. For anybody who doesn't know what's a jack-o'-lantern is this pumpkin that kids decorate during Halloween. Of course, I know both look very orangey, and that's the reason why it's probably gonna, just looking at the texture and the color and saying it's a jack-o'-lantern, but it's actually not a jack-o'-lantern, right? So in this, and it's very confident. It says 99% it's a jack-o'-lantern. And then it tells you it's orange. So ideally, in this case, what should have happened is this should be tagged as an error. And then what's going to happen is your client is going to say, hey, your model is not doing well. So in that case, what you say, okay, let me look at what happened. You will be getting all of these images on your server side. You now create a small bunch of images corresponding to the ones that went wrong, and you generate this V2. And this V2 update, you don't even need to create it locally. You can actually just send a YAML file to the server. So it will generate the V2 for you and also get it out in a Canary Build format so that your users do not see any downtime, and this prediction improves greatly overnight. So this would be the process in which, even if you had to deploy something very simple as a computer vision, end product, you can now be able to do that on a regular rolling fashion and make sure that your clients are happy, even though you didn't really have to build anything from scratch on a local level. right? So I'm hoping this helps, solidify the idea of the Kubernetes that we were talking about so far. So in order to summarize, what we should see is when we are creating machine learning models are definitely important. They help in automated decision making and personalization to a huge extent. But some of the things that we should be very cognizant of when we design ML models is you should create ML models that scale at system level. This is actually the knowledge which is somehow missing and that needs further training, is there is a need to scale at a system level. You should understand what happens if tomorrow my client switch from 2 to 20 to 200 to more. Do I have a system that is going to support that? So the idea of Dockerizing files, the idea of creating containers should come on as early as possible so that your code is built to support something like that. Otherwise, the amount of downtime you will face is going to be huge and you will not be able to upkeep with your client requests. The second thing is always create modular solutions. You should be able to create modules that then can fit into some other product as well. If you think about the whole thing as end-to-end, which is also not a bad idea, but it might so happen that if something fails, you don't know how to debug it. Even for Kubernetes, whenever you actually look at the whole data flow, you should be able to go into each and every submodule and debug it. Otherwise, it's going to be very hard for you to figure out where did the logs go wrong. So always think of creating a modular solution. And then the best practices always includes baselining. What baselining means is always ensure you have a simple model to compare versus as well. So instead of coming up with the deep learning example as your first resolution, you can even try something simpler like a statistical learning model where you extract features and you just pass it through a sample classifier like a support vector machine or decision trees. So using very simple baselines have always found to be better because then they are very easy to scale. And the errors that creep up is rather lower. And always remember, there is a shift from model-centric to data-centric ML in production. You may hear these terms a lot, but not really register what it really means. Model-centric means your aim in life is to take all of the data that is available to you. So give me all of annotated data and iteratively improve the model. However, what data-centric says is, I don't need all of the data. Give me batches of it, ensure that they are clean, they have good quality control, they are the same kind. And now let me iterate through different kinds of data. And I don't really care what model I'm using. Maybe for one batch, I use logistic regression. Maybe for another batch, I use, ResNet. And that's completely fine. And, for this particular batch of data, this particular model is giving me the best result. I'm going to go with that. However, so you're iterating through batches of data rather than iterating through batches of ML models. So that is the whole summary of how to do end-to-end product creation and what are the couple of things that we should be cognizant of while we do these creations. So I'd like to pause at this time and give it to Vishal and see if there are any questions. Let's open it up for Q&A.
Yeah, there are two questions, so it was a very wonderful session, and I have got some questions here.
Okay.
Vivek Kumar is asking, can you explain why overfitting is happening?
So when you're talking about overfitting, are you talking about with respect to let me talk to you about overfitting for general machine learning cases, and then we will get back to, what is the overfitting that happened at that particular scenario. So overfitting can happen due to multiple reasons, but for most of the case is when you have, let's say you've gone through a lot of epochs. If you're using deep learning, if you've gone through a lot of epochs and it's only having one kind of optimizer, so you have not done enough hyperparameterization search. So hyperparameters, it could be the compiler, it could be the learning rate, and again the curve. So that's the reason why you should always, whenever you're training an ML model, you should always consider splitting it. So there should be a train validation split, right? So what happens is you can actually overfit for a certain amount of data while you've not really seen or not really regularized it for a little more generalizability. So the best, what you should really do is whenever you have data, you should always split it into training and validation, and always see if the loss curves of the training and validation are going in a similar format or not. If you see that the training loss is reducing, but validation is very straight, that means you're overfitting. So you should always understand that having too many epochs is not always a good idea. You should always stop whenever you see this trend between training and validation changing. So ideally, as long as training and validation both are going hand in hand, the trends and patterns look similar, you are not overfit. As soon as you see that patterns have shifted, one is going up, one is coming down, that means you have started overfitting. It is not generalizable anymore. So that's exactly what happens for the for the overfit case in here as well. So there was Target, there was Walmart. You know exactly what to happen for Target. So you overfit for Target, but your solution does not know how to now generate or now to cater to a new store, right? So in this case, what if you had to correct it, you actually have to go back to feature engineering level and then improve from there rather than just looking at the loss curve. I hope that answers the question.
Perfect. Yes, it's perfect answer. Another question which Swati Pandey is asking, will rolling update cause latency since the response will be produced after the code runs through both the versions?
Actually, no. And that's the beauty, because you see that all of these were pods, right? That's actually an excellent question. I'm glad that means you followed. What it means is whenever you have a virtual machines, you can have multiple pods in there. So you saw all of those containerized, images. So what V2 comes up as a new pod itself. And these are parallelly processed. There is no, you didn't see that first it goes through V1, then it goes through V2, right? So there is no serialization. It actually happens parallelly. And once all the metrics or the unit tests are checked, once you say, okay, it meets all of the standards, it automatically switches. So that's the reason why Canary builds, they do not take more time. They are actually much more efficient because it comes up as a new service. And you might think that, in this case, the V2 was better, but it could also happen that V2 is now ending up with more errors, correct? Think about the Samsung S7, fiasco. So something like that. If that had a Canary build, what should have happened? That would have been recalled completely. So S7 should not have gotten released. So if that was a software bug, in that case it was hardware. Hardware is much harder to roll out. But if you're talking about software, you can very easily control them in those cases.
Yes. So there is another question which is coming from Madhvi Monish. Can you explain how you got into ML related career or how you started?
Okay, so this is getting into journeys now. Well, I'm glad that at least you found relevance to whatever we presented today. Machine learning was something I got into by accident. I'll be very frank. When I was doing my undergraduate, I think by the end of my career at BIT, I had published 2 conference papers. They were both IEEE conference papers. So I was very interested in wireless communication. So I was working with Dr. J.S. Roy, and it was wireless communication is what I wanted to do. So when I applied for US, for GRA to come for my master's, I got into wireless communication. But then wireless communication did not have funding. This was back in 2008, and there was a lack of funding, and that's what I saw, that it was not going to get any better. Um, Somehow by that time, the only other division that always had money was that interdisciplinary field. So whenever you are working as an electrical engineer, so that's what my training was. But then the other divisions such as computer science, or the other divisions such as there's epidemiology. I started my master's at Kansas State, and that's where we saw neural networks was actually the first course that I took in the first semester. And it was the PhD level course. It was super hard. Every single day, I think the class had 20 people, and every single day we would come at the end of the day and we'd want to just run away. It was so hard, but it was the best learning curve. It was how, the prisoner's dilemma, how game theory works, and neural networks, the whole concept we learned in 6 months. That was the huge eye-opening and the game changer, I would say. And after that, it was just, I wrote a lot of papers during my master's. I think I was able to write 5 conferences and 2 journals. And that just helped me get my PhD into machine learning at Minnesota. So I think it was by accident, but now I understand why there is funding to it, because there's always so much scope. But as I said, you will see a lot of research papers for machine learning and AI, but not that many products. And so that's what we are trying to do, even to our company, is to do this upskilling to bridge the gap, so that people who are making these demos can also now create successful products. I hope that answers your question.
Yeah, yes, ma'am. Ma'am, Gropi Krishna has asked, does rolling can happen automatically when deployment occurs?
Yes, yes. And that's what the Kubernetes orchestration allows. So what Kubernetes does is that this YAML file, YAML, so it's called a YAML file build. What typically will just happen is if you take a YAML file build, you just put these metrics in it. So you point it to, let's say that, you have new data, right? So you place this data in a bit bucket. I'm talking about GCP right now. Again, same thing will apply for AWS. You place all of your data in a bit bucket. You give the path to the bit bucket. And you also say that these are the hyperparameters that I need trained. And then this many number of epochs, this many number of samples, and you just upload that to the server. So you don't even have to do anything locally. You just upload that YAML file to the server. And then what the server is going to do is it's automatically going to generate a build for it. If there are any breakages, it will tell you. But if nothing broke, it will then automatically make sure that a canary build will be built after that. So that's what the beauty of Kubernetes orchestration is. You don't really need to do anything locally. Everything can actually happen on server side. Any
Yes,
more
ma'am.
questions?
Yes, ma'am. Anshuman Kumar is asking, which is a better practice, deploying the abundantly available cloud sources or training one's own model for objectives like visual search?
Well, visual search, that's actually a great question. Ideally, you should be able to fine tune it. So the first model that you deploy should not be just something that's taken from someone else. Like the example that I gave you, right? So the beach, it was telling you sandbar and everything. That's just ResNet 50. That's it. I just took ResNet 50 and I deployed it. And you saw that it was not doing a good job. There are multiple reasons. And again, it comes back to the data drift and the concept drift, because the underlying background data is very different, right? So for instance, you saw the standard images that it's been trained on. It's pretty, these small thumbnail kind of images, right? But now as soon as if you are looking at full blown large images, or if you're looking at video streams, the pixelations are different. The compression factor is different. So there's a huge amount of data drift, because of which the good practice is to take transfer learning is huge in deep learning right now. So you pick up an existing deep learning model, but you should always also fine tune it with some amount of local data. And this fine tune again, if you want to do it as a Kubernetes orchestration, you can just do it on the server side. But the first version, you should always try to generate it locally, or even on the virtual machine in a cloud. That's fine. So right now, all the cloud providers make it super easy for you to just start a virtual machine and open a Jupyter Lab. So GCP, they call it Jupyter Lab. You can now have a Jupyter notebook in GCP, or even in AWS and SageMaker. So you just open a notebook, and then you just create your model there and then upload it. So containerize it, Dockerize it. That should be your V1, but it should always be fine-tuned for some of your own data set. Otherwise, it's probably not going to do as well as you want it to. I hope that answers your question.
Yeah, ma'am. Thank you, ma'am. Ma'am, if you have something more to explain, you can go ahead, or we can take the questions later on.
This is fine. I wanted to keep the last 15 minutes open for Q&A. I do see some questions in the chat right now. I will try to answer them. Is software engineering knowledge required for machine learning engineering jobs? Okay, so these are two, it's actually a good question at an undergraduate level if you're thinking about them. Software engineering means something very different when once you are into the field, and machine learning now means something very different once you're in the field. So software engineering is when you know how these orchestrations across different software platforms. But machine learning, the core understanding behind it, the packages that you're requiring to deploy, they're very different. So if you know software engineering, you probably will do a good job at machine learning, because you know the process, you know the software development life cycle, the development, training, and deployment. So the constant push and pull between dev and testing. So you will have known that, so you will appreciate the process and understand it's not an overnight system. However, the systems required to do software engineering is very different from the systems required to do machine learning. So that's the reason why we say, okay, machine learning should be done by people who are domain experts as well. Machine learning should be done by software engineers as well, because they already know what to expect, and then the journey becomes much easier. But yes, coding is one of the basics. Python coding, it's super important. Getting more accustomed to TensorFlow or PyTorch. If you're into NLP, natural language processing, you'll see that PyTorch is generally a favorite. If you're into computer vision, you'll see TensorFlow is typically a favorite. So, figure out what is the domain you're interested in, and knowing that these are the libraries and getting as much hands-on experience with them. So you don't really need software engineering experience to be an MLE, but if you do, then the process becomes easier to learn, I would say. I hope that answers your question. All right, so then I do see a question. What is transfer learning and why does it matter? Oh, this is a great question, actually. So transfer learning is the process where you transfer the knowledge that you've learned from one data set and then you apply it to another data set. So nowadays, like, Google, Facebook, what they have done is they have huge processing power, right? So they have harnessed all of that. And now what they've been able to do is, very recently, Facebook released this million images or billion images, I guess, from Instagram that they've mined now in order to detect faces. And as you know, face detection is getting harder because now there are masks and all. But what is possible to now do is you do not need to start training from scratch anymore. You can just start from the weights and the biases. These are called checkpoint files that once these larger companies, once they have trained models on them, they've literally created a checkpoint file, or it is just a file that contains all of the weights and biases of all of the neurons. So all you can do is just load these checkpoint files and then load some of your data, and so that your neural network now does not have a cold start, but it has a warm start. What a warm start means is now your weights and biases are not initialized randomly, or they're not initialized to 0, but they are initialized to something that is actually true for object detection. However, you may say that object detection for medical images, like I showed you pathology, right? That was very different from detecting a cat. However, if your system knows to look for texture, if it knows to look for color, then these are neurons, the weights and biases that your system needs to learn anyways. And now if you're using a pre-trained weights from a cat model, you already have those weights comprised. So now all you can do is just reload it, or fine tune it on some of your own data, and you will now see that you are now able to have a good deep learning model with as few as a few thousand images. Always remember, the amount of data required to train a good machine learning or good deep learning model, ideally there is a 10:1 ratio. So the number of parameters in the neural network, ideally you need 10 times of that number of parameters to have a number of samples in order to train an ML model well. But if you look at a very traditional AlexNet, it has, I think, close to 600,000 or 6 million parameters. So where do you get 60 million images to do train on? So that's a huge number of parameters, so that you don't have underfitting or overfitting. So that's the reason why, if you use transfer learning, because you already know the weights have learned already from a previous batch of data set, you know that now you are going to get a decent performance, even if you train it on as few as, let's say, a few thousand images, 2,000 images maybe. So that's the reason why you need transfer learning has become very popular, so that you don't have to do anything from scratch, but it gives you a warm start. I hope that answers the question. Okay, I do see a few other questions. All right, great. What are your views on Hadoop? Hadoop is actually still used, I would say, but PySpark has taken over the industry by large. So my personal choices over the last few months, I've been working on PySpark on AWS. So EMR, it's called the Elastic MapReduce. That's a resource. That's just the name of the resource. So what Elastic MapReduce will do is it will allow you to do decentralized computing. So let's say you have 22 million samples. How do you make a recommendation engine out of all of them? So what you will do in those cases is you will just take snapshots, or the compute becomes decentralized, and Elastic MapReduce allows you to do that. But again, ideally, PySpark has taken on by large, so you can now create RDDs, or relational databases. You have data frames, data sets. They look just like a pandas library, and then that makes life so much easier along with BigQuery. So Hadoop, it's typically helping you with MapReduce and all of those functionalities, but PySpark is definitely dominating the industry by large right now. Okay, then the next question, I see data structures and algorithms. Is it important for data science or ML jobs? Do we need to master it? Data structure is super important. And especially if you're trying to get into the FANG companies or any of the larger institutions, then absolutely, you cannot think without it. In the Bay Area, the coding rounds are super hard. Data structure is always a part of what's asked. So that helps you. And you may ask why, why do I need to know data structure? It helps you create optimized code rather than generating a code that has too many lines. It's good coding practices so that your containers are well tightly built. So yes, if you're trying for the large, bigger companies, FANG companies, you definitely need it. How complex deep learning architectures deployed in hardware? That's an excellent question. Hardware architecture or deployment. So we're talking right now is serving. So let's say that you have a TensorFlow model and now you need to, deploy it on a Raspberry Pi. It's a hardware, right? So which is going to give you a blinking LED. So red means it's working, or green means, red means it's not working, green means it's working. Now, what typically happens is, again, from the autonomous drive industry, I can tell you my experiences from there, is let's say it's an object detection for video frames, right? And what we saw is the model that we built, it was, let's say, 400 megabytes in size. So as soon as I froze it and then I have the checkpoint file, it's 400 megabytes. That's a huge amount of memory that needs to be now taken from my hardware. So in order to put that into an NVIDIA Drive PX2, that's going to take a huge amount of storage. Then, I don't have storage to, store the outcome of my model. So that's not the most efficient way. So now most of the cloud platforms and most of the libraries are also offering this concept of quantization. So quantization, for instance, for TensorFlow, if you have a TensorFlow model, there is this flat file format which is called TF Lite. So TensorFlow Lite. What TensorFlow Lite does is it can literally reduce the amount of your size of your file from 400 to 40 MB. And it does that because it does scientific computing. So let's say you have 0.000000098, it's going to truncate. It's literally going to start truncating after a few decimal points. What's the downside? Some accuracy is going to get compromised. But you will see that your model size gets shrunk by a huge margin. And now you can actually make it fit. If it's something 40 MB, or if it's a much lighter model itself, then hardware deployments become much easier. And also, if the model is smaller, we see the latency around it is very low as well, because on an online platform, you don't really see the read-write latency, right? But as soon as you're looking at the hardware, there is a read-write latency, and which has to be taken into account. So that's the reason why complex deep learning algorithms, you should definitely take care of making a quantized version out of whatever model you have, so that latency is minimized, as well as the deep learning solutions are more deployable in industry. So that was a great question. Thank you. Where to use reinforcement learning? Okay, so I think I wrote a blog sometime back in just to explain what are the different kinds of machine learning, and reinforcement learning is used in most of the real world applications. So if you're talking about a virtual assistant, or if you're talking about any application that is supposed to get better over time. So reinforcement learning is the way in which human brain learns. So think about how a child learns how to walk, how to crawl, all of that. That's a key example of reinforcement learning. So whenever you are getting better with more data coming in, but understand reinforcement learning is very different from traditional machine learning. It's not supervised, unsupervised. It's a very state space based method. So you're in a particular state. That means I know nothing about this new task. I have this new task. If I do this, I get this outcome, right? So let's say that there's a hot surface and I don't know that if I should touch it or not. So my state spaces, I don't know if it's a hot surface. If I touch it, then I'm going to get it's going to burn, and then I should remove it, right? I should remove my hand. Now the knowledge I generated is I should never touch a hot surface. So this process in which there is a state, then there is an action, and then there is a reward function or a penalty function based off of which you know that this action should be preferred, and then the next action should happen or not, then that is reinforcement learning. Otherwise, it just becomes standard machine learning. So some of the use cases of reinforcement, again, robotics is purely based off of reinforcement learning, because robot is learning how to open the arm, close the arm, do all of that. But the other places, whenever you're doing text to speech, so TTS, or natural language understanding, natural language generation, in these cases, reinforcement learning is tremendously used. How does CD get to know what you want, and your CD gets to know better what you want, right? And that's just because it's over time, it's optimizing for your behavior. So wherever there is personalization, wherever there is you want a certain task, and it's different kind of environments you want it perfected, reinforcement learning does come into play. Video games is another aspect where deep reinforcement learning is used a lot. So there's a lot of material already out there. If I had to suggest, then there's this deep learning bootcamp. Again, it's a free playlist on YouTube. It's by UC Berkeley. You should check it out. I really found that very, very insightful when I was doing my brush up. So I hope that helps. Anything else? How long more do we have, Vishal? Should we keep going, or when should we stop the stream? I can keep going.
Yeah, fine. We do not have. We have time till 9:30 actually.
Okay, let's take a few more and then.
We can take more questions.
Okay, all right. All right.
If you're comfortable.
Yeah, sure.
Only if you're comfortable. Yeah.
Okay, right.
It's early morning for you.
It is. I will have to leave maybe in 15-20 minutes, but yeah.
Yeah.
Okay. So one doubt, is it necessary to do DSA algorithms in Python or C++ Java? As I do my competitive coding in Java and C++, should I jump to Python? Okay, this is a very, very important question. It's a very career-focused question. C++ is important if you are trying to get into machine learning that hinges around hardware. So if you're interested in autonomous drive, anything that will have this software that has to be then put into hardware, C++ is absolutely necessary. I have seen a lot of people who are getting into deployments in autonomous drive. They were working on Python, but they had to scale back to C++ because that is where the industry is driven. Because you're at the end of the day, you're actually writing at the hardware level. So C++ is the only one that can work with drivers. So extremely important if hardware-driven machine learning is what you're interested in. So anything that required Raspberry Pis to be modeled and created, very, very useful. Now, Python resides on the application layer, right? So, there are multiple layers to coding this. So there is this hardware layer, then there's middleware, and then there's application layer. So Python is very, application layer. So if you talk about the Drive PX2 or the NVIDIA's Drive PX2, it is compatible with Python and it is compatible with TensorFlow. So both of them, so you literally don't need to, break down and open up the middleware, or you don't really need to code at the driver level because that software stack takes care of that automatically. So, but then in that case, deployment and everything, happens at the application layer. So if you want to work for a company that uses NVIDIA Drive PX2, Python is important. If you want to work for NVIDIA, C++ is important. So I hope that helps you understand. So I think having a good knowledge of both, but I understand you cannot know both equally well. If you want to work for a hardware company, C++, you should definitely have Intel, NVIDIA, all of the hardware companies. Absolutely necessary to have C++. Okay, next question. With rapid developments in MLOps, GCP, Azure, do you see roles of data science shifting more technology-driven to business-driven? I do, and that's actually a great question. Do you see data science shifting more from technology driven? So it's more ML driven to data driven, I would say, but understanding the business case, yes. And in most cases, what happens is it trickles down. So let's say that there's a, the manager, as a manager, I understood the problem. I would take it to my team. There would be a principal, and again, there would be team leads. They would understand what needs to happen in the subgroups as well. But tying it back to the business case is understanding or visualizing, or in terms of what your bosses can use or something that is going to tell you that this is, the advancement that is happening is super important. And I think that is something that needs to be trained more as a part of our traditional education. That needs to be ingrained into the people a little bit more, is asking the right questions. Often we say, okay, we get so tied down, or we get so enamored by computer vision. We say, okay, I want to train a model. I want to create a new model that does X, Y, Z. But the question is, why do you want to train the model? Maybe there's already a model that is trained. You just need to, get the weights from it and reload it and work on it. So do you really need to train? So asking the right business questions, super important. And this is a communication. This is actually a mindset that, again, through our program also we are trying to imbibe into students, is asking the right questions, and asking the right questions with subject matter experts so that you don't waste their time, but you're asking, using their time more wisely, and producing work which is usable, which is modular. So absolutely useful to understand the business case. But again, I can also see that the business case might be open to interpretations. For a biz dev, the interpretation is different from the actual developer. And so that's why keeping communication stronger is super important. And I cannot stress enough how much lack of that we do see in the industry. So communication, super important, to be clear and visualizing everything that you have, so that you can explain it in a better way. So things go a little more seamless. Thanks for the question. That was a good question. I'm curious to know what evaluation approaches that you work to gauge the effectiveness of a machine learning model. Okay, so you did see that I talked about monitoring, right? So ML monitoring, that's super important. Now, some of the metrics we always talk about, very easy ones: accuracy, precision, recall, receiver operation characteristic curves, ROC curves, precision versus recall. All of that does come up very easy. However, if you are monitoring at production time, you don't really have ground truth. So there is no way for you to know what the accuracy is, right? So think about you're working on predicting on a portal, if people are going to buy stuff or not. They've not really bought it. So how do you know if it's accurate or not? You will know it's accurate or not sometime later. So what are the metrics that you can really look for in this case? The metrics that you should look for is the probabilities. How high is the probability, or is the probability within the range that you expect it to be? For instance, I'll give you again, the object detection app that I showed you, right? So it's at 77%, it was beach, it was right. So ideally confidences are supposed to range, between 70% and 90%, or maybe even 99. But if you just had taken the top accuracy, you would have said, okay, then I'm unclear what to do. However, now if you see the top three, probabilities, you see that for the beach image, it was a little better. But as soon as I showed the medical image, it said 99% it's a jack-o'-lantern, and the rest was like 0.0000. So that should give you an idea, is the distribution of probabilities for a batch of data that has to be in a particular range. And if that falls off of that particular range, then you know that your model has to be retrained, or this particular data is not, it's not conforming to the model that you've trained on. So these would be a few metrics. So probability is actually a huge facet that needs to be monitored for. That was a good question, actually. Is there a relationship between convex optimization and machine learning? So ideally, well, there's no clear answer here. Convex optimization assumes that the space is convex in nature, right? So entropy always keeps getting better and better. But that's not something that you can always assume for the feature space. Feature space can be convex, it can be concave, it can be not explainable. So those particular features may not really mount to something. That's the reason why deep learning is so favored, because it's able to find these complex relationships between neighboring pixels without really having to say what you are trying to do there. So sometimes, and this is what we've seen, especially when the disparity in data is huge. For instance, the number of people who are coming to a shopping portal could be 99%, and the number of people who are literally buying something less than 1%. Huge disparity, right? So as soon as we started doing a convex clustering, we did start seeing is that the nature of the space was not very regular. It was not convex. So the features that I'm using to represent the space is not convex. But even in this case, there are ways, if you're doing PCA, if you're doing TSNE, there are all these nearest neighbor based methods that should be preferred more over standard approaches like PCA. So that you get a well-mapped space, which is more convex in nature. So the answer to your question is, it's not always necessary, but if you can map it to a convex space, then yes, only in that case your loss will reduce, and you will see the standard curve structure as required. So feature engineering becomes a very key part in order to ensure that your space is convex. But yes, it's not always true as a starting point, but that is something you should try to strive for or try to get into if you get good features that are engineered. That was a good question again. Anything else? These were all of the questions in the chat.
Yes, ma'am. I think so. These were the.
Yeah, go ahead.
Yes, sir. I think we can now finish it. You can.
Okay. I did see one question. Can you suggest the best book for data science? Honestly, there are so many. I wouldn't be able to say, okay, this is the best book versus not. Data science, there is a lot of material already out there. So towards data science blogs, Medium blogs, they're pretty good as well. But it's more about keeping current about what are the latest research that is happening. So reading more on archive, or reading more on the and publication standpoint will give you a little more understanding as to what are the applications that are happening. So I think that's a better practice than starting with a textbook, if you may say so. It's a very applied field. So, and it changes across application domains so much. So I haven't read the best book on data science. If I do, I'll keep you posted on my channel, but I haven't read the best book on data science, to be honest here.
There is some few more questions popped in.
Okay.
Someone is asking, is Adam superior than other optimization algorithm?
So Adam is a kind of, so that's an optimizer, right? It's not an algorithm, it's an optimizer. And Adam is a kind of adaptive, correct? So there is SGD, there is, there's RMS prop, and then there is Adam optimizer. And then there are different variants of Adam as well. You will see it is used the most. It is the most common one. Is it the best? Sometimes yes, sometimes no. Adam optimizer, you will see that if you're using Adam, then the values should be, iteratively very small. The learning rate should be ideally something 10 to the minus 5 or 10 to the minus 3, but it is also slower. SGD is faster. So if faster convergence is required, then going more towards RMS prop or going more towards SGD is preferred. Also, the final local minima that you achieve is, so for Adam, it's adaptive, correct? So what you've seen is the surface, it's more curved in nature, but SGD will take you to a more flatter optimal global minimum. And again, everybody, both compilers or both optimizers can give you different local minima, and that's the reason why if speed is of essence, SGD, RMS prop. If performance, or if you can go slower, then Adam should be preferred.
Rochak is asking a very good question. He's asking how much time does it take for a beginner to learn AI if he has just a basic knowledge of Python?
Okay, so AI is the broad spectrum. Maybe I should have started from there. So AI is an umbrella. Under AI, then you have machine learning, you have data science, you have knowledge discovery from databases, you have cognitive sciences, you have all of these, right? I actually have a video about this on my channel as well. Check that out. So if you're talking about AI, what aspect of AI? If you're talking about machine learning, then it's a little more defined. Reinforcement learning, again, definitions are different. You should choose, pick where you're more interested in, and then based off of that, you should focus your attention towards. Minimum amount required to at least get to the operations level is 1 year of Python programming. That's what we say. So if 1 year you've been toying around, if you have different kind of GitHubs, if you have tried out different data sets, if you understand how to load the libraries, how to write definitions, how to write functions, how to write classes, if you know how to do that, then in that point, you can actually start getting more hands-on experience, I would say. But tinkering for at least 1 year is what we say is essential. I hope that helps.
First is asking, how do you tackle the problem of avoidable bias while working in real life projects? It affects the prediction, yes, but one has to achieve perfection when working for a big organization.
Yeah, absolutely. So when you're talking about bias, are you talking about bias in the data, in the model, or what kind of bias are you talking about?
I think he's talking about bias in the data.
Okay.
Because he's talking about the prediction of the organization.
Right. So bias in data is a huge problem, right? And we do see these a lot in most of the given applications. So that's the reason why the first task that any data scientist or any machine learning engineer should do is always EDA, exploratory data analysis. Exploratory data analysis is going to help you understand what are the different biases, how many different classes, how many different categories, and then how many kinds of each and every one are there. So now if you're able to find that out, and now all of a sudden in a particular data batch, if you see that that distribution is shifting from what you had assumed, then you should ideally use models that are more sensitive to data biases, or more insensitive, I should say, to data biases. For instance, typical models that are used a lot in the industries, logistic regression and decision trees. Random forest decision trees I've used a lot in a lot of different projects, just because of the fact that there is this concept of bagging and boosting. So if a particular tree gets formed from a sample that has low number of samples in the whole class, then there is a way you can actually boost its performance, right? So boosting, bagging is a concept that should be used, or aggregation should be a concept which is used, so that you can then get rid of bias in the underlying data. And again, understanding what the underlying distributions in the model are and constantly monitoring for it. So at any time, if you see a batch of data is widely different from what the data distribution you had assumed it to be, you know that your model is not going to do well in this case. So raising those flags early on and creating those exceptions is super important in this case.
So any pass on your hi to Tanisha. She is saying,
Okay.
Tanisha is eagerly waiting for your talk. So I hope she's there.
Well, this video is going to be on YouTube, and I'm hoping we can watch this offline as well.
We'll take a couple of more questions and then we can
Let's
wind
close
up.
it. Yeah,
One
let's
question
close it.
coming from the current trend. It's visible that lots of processes are shifting to quantum computing from classical computing by launching quantum computers on cloud. So he's asking, do you think that the nature of machine learning and data science will see a paradigm shift in the near years?
Once quantum computer comes up, I definitely do see that. And the major advantage it's going to happen is on the amount of training time, because if training times, epochs, if you have larger loads, it takes a huge amount of time for you to, or the resources required to finally train a model. So that will get reduced to a huge by a huge margin whenever that happens. So of course, quantum computer on for the hardware aspect, it has a huge benefit. And whenever that does, but again, till the time being, we can just keep with what we have and keep using the cloud platforms. What I can say is the cloud platforms are also modifying themselves constantly in a way that the front ends are shifting, in the way that the ease with which people can integrate to them is becoming easier. So even if the background happens or the backend happens on the quantum compute versus a standard virtual machine, I'm sure that the cloud computing platforms will make it seamless, so that it has to be agnostic to the people, or the application layer should be agnostic to it as much as possible. So keep using it, and the major advantage that I see is going to be a downtime in the amount of training and the number of epochs it requires. Right.
Last,
Okay.
which is coming from what makes more sense, a PhD in machine learning or a PhD in mathematics or statistics?
Okay, that's a heavy one. Well, I am not a PhD in mathematics, so again, my outcome is going to be a biased one. But I would say that doing a PhD in something which is more applied is going to make you more market ready, because now the industry partners will know that, yeah, you worked on this application use case, you worked on computer vision, so probably you can scale it to our application. But if you're doing something in mathematics, you're getting more into the theoretical side of it, which is equally important. There is nothing, if algorithms were to shrink, then what would the applied people use? Right? So both are equally important, but I would say that you become more market ready if you work on an applied field. So doing something on a applied machine learning might become just an easier fit to transition into industry. But if if you really want to get into faculty, academia, research, core research, then mathematics is the way mathematics is the way to go for it.
Basically, he should have heard your earlier talk when you said that you were inclined towards wireless, and then you should.
That's right.
As a teacher, I would say whatever you get interested to will be more useful for you.
Yeah, absolutely. I absolutely tell all of my students is, go by the uncertainty principle. Our heart knows what not to do. We always are inclined to figure out things, but it's very easy for us to know what we don't like. It's hard for us to know what we do like. So try it. If you don't like it, then don't do it.
In fact, even after 41 years of my age and 17 years of teaching career, I do not understand why I am into this line. I'm more of manager sort of thing. So you never know what you are doing and what you are best at.
That's true.
So it was an impeccable session, and I'm very, very glad to have you on the platform. And some of us on the chat is writing, they're eagerly waiting for you to see in Mesra. I hope that happens very soon in the near future. And at the same time, on this online platform, I would request you to wherever Mesra students require, I'm sure you are always available. So now I'll be dropping a couple of more things I will be expecting from you, and definitely I'll get back to you for that particular help.
Thank you so much for having me here.
No, I'll take your help for very often now, because see, you have said that you have taken the project under J.S. Roy, sir, and he was from my department. Okay. And you are, yeah, so everything was fine. So let us have a more interaction with you for BIT Mesra students, and I will be taking, because ML is one of the most buzzing word as of now.
Yeah, true.
So my students will require you for projects and different other help wherever required, and definitely you being their senior will, I'm sure you will be always helping them out.
Well, look forward to it. Thank you so much.
Back to my team for proposing a vote of thanks. Ishita, please propose a vote of thanks.
Yes, sir. So as we proceed towards the conclusion of the event, I would really like to thank Mr. Sohini ma'am for her wonderful talk on machine learning. It has been a wonderful opportunity, and I am sure all of us here have gained a lot of knowledge. And I would like to thank you for your valuable time that you have given us today. We know it's morning there, so it's like, thank you very much for coming here. And now I would like to thank Vishal sir, because he has been a pillar for all of us in the SARC team for conducting this webinar. He's been involved in the registration, invitations, as well as introducing you with this platform and with the YouTube Live. So he has really helped us a lot. So thank you, sir, for being here and for helping us all out and making it easier for all of us. And I would really like to thank the participants who have posed up multiple questions, such in like mindful questions for ma'am as well and for all of us. And in the end, I would like to thank the team of SARC who have worked on this, on organizing this event since a long time, since the poster, email registrations, as well as maintaining it right now with the YouTube and Zoom simultaneously. So thank you, everyone. Thank you, ma'am. Thank you once again.
Absolutely, my pleasure. Yeah, and I think now digital realm becoming much more accessible, I think YouTube is a great platform. So I'm glad we were able to connect here.
Thank you, ma'am.
Okay. Thanks so much, guys. And I will